not doing that. Something that I find quite unsatisfactory is the following. So you have got your this thing RSS and RSS1, both are residuals. So I have got this RSS. Now where does this RSS live? This lives in the orthogonal complement of column space of X. So this is inside actually a space of dimension n minus rank of X. So this fellow resides in a space of n minus rank of X. So we might say that there are actually only n minus rank of X many free quantities inside that vector. This is the norm square. But this vector, though it's an n-dimensional vector, but only n minus rank of X many terms are free. Similarly, if I consider RSS1, that also consists of n minus rank of X1 in this case. So X1 is just the empty matrix if you are working with no intercept case, and if you are working with intercept, X1 consists of 1, 1, 1. So this rank of X1 is either 1 or 0. And these people suggest that you divide by these numbers. And that is the quantity that you get like that is called, I will write it here, I will call that R square adjusted. It is the same thing, 1 minus RSS divided by RSS1, but I will divide by their appropriate degrees of freedom. That is the dimension of the space where they reside in. It's called the degrees of freedom. And here n minus rank of X. So you can get an R square adjusted here, and R square adjusted here. The numerator will remain the same in both the cases, but when you are using no intercept, remember that this term becomes 0. So rank of X1 is 0 when you have no intercept, and it is 1 when you have intercept. So this kind of adjusts for them. So if you put lots of terms in it, in that case what happens is that this n minus rank of X increases, so this decreases, and though RSS decreases, so does this thing, so the ratio is kind of controlled. So that is one way of taking that into account. It is called R square adjusted, and this is something which is often, you see that it is actually printed as output of various things, various softwares like R. So here I am just reminding you once again the dimensions. So for this fellow, this thing, the dimension is n minus rank of X. For these or these, it is n minus rank of X1. If it is, this is your X1, in that case n minus rank of X. So if you are considering this, its dimension happens to be n minus 1. And if you consider the entire thing, its dimension happens to be n. So you are either dividing this thing by n or you are dividing it by n minus 1. Accordingly, you get R square adjusted.